2 of the Chapter 8 review. It's raining outside, so I don't know if that's going to come through. This room gets kind of loud when it rains. 73 too at July 4th at 1 in the afternoon, which is just amazingly shocking. So each of these problems, just like most of the problems on this review, I can get the answers ahead of time. I'm going to do that just to make sure that I'm not messing up my algebra. So to get started on problems 13 through 16, I'm just going to enter all the matrices in that are in this group of problems. And there. So I'm going to just go to Edit, Names. A is a 3 by 2 matrix. It has 3 rows and 2 columns. B is a 2 by 2 matrix. C is a 3 by 3. D is a 2 by 3. It has 2 rows and 3 columns. E is a 3 by 3. And F is a 3 by 2. So I'm going to just enter these matrices one at a time. So 3 by 2 for A. You'll hopefully do it right. And you should be able to tell if you have the dimensions wrong if it doesn't look the same. So I've entered A, second quit, then second matrix edit down to B, which is a 2 by 2. I actually already have that in 4, 5, 1, and 2. Second quit, second matrix edit C, which is a 3 by 3. And since I probably wrote a key for this recently, I have them in already. 1, 0, -1, 7, 2, 4, 2, 3, -5. Beautiful. Now I'll do D, second matrix, edit, go down to D. D's a 2 by 3, my D's not right. So 2, enter, 3, enter, and then 3, 2, 0, 4, -1, 3. Looks good. So I've already been playing with these, so my matrices didn't need as much work. But you should be able to enter these hopefully just fine. If you can't enter these, come visit me, because that's going to be an important thing to be able to do on the test. So my E is whacked. And once I get all the matrices in, I'll do each problem via my calculator and by hand just to make sure. Perfect. So I have all the matrices in my calculator properly. The first thing I'm supposed to do is 2a minus 3f. So I'll do 2 second matrix names A minus 3 second matrix names F. So I can make the problem more or less look like 2a minus 3f. And my answer is supposed to be that matrix. So my goal is to write this down for an answer. -1, 6, -9, -2, -6, -19 is my hopes that I can get that by hand for problem 13. If I do it by hand and get that answer, I'll believe that I'm correct. If I do it by hand and don't get that answer, then I'll start looking for a mistake. And it's probably, if there's going to be a mistake, it's probably not with my calculator. It's probably with my general work. So for 13 to do 2a, I'm going to write a 2 outside the A matrix, which is 1, 0, 3, 2, 6, 1. Put my minus sign and then the 3. And then the F matrix is 1, -2, 5, 2, 6, 7. I'm going to do both the scalar multiplications. Multiply the first matrix through by 2. Get 2 times 1 is 2. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. And then 12 and 2. I'm not going to work with the minus sign. I'm going to multiply the bottom matrix by 3 and then worry about the minus. So I'm going to go 3 times 1 is 3. 3 times minus 2 is minus 6. 3 times 5 is 15. So I'm kind of doing the multiplication of 3 before the subtraction. So now I have the scalar multiplication done. I'm going to come up here and do the subtraction. Upper left is going to be 2 minus 3, which is going to be the -1 part of my answer. Upper right is going to be 0 minus -6. That double negative is going to go positive. That's going to give me the 6 part of my answer. So that my top row of -1 and 6 is correct. Next, I'm going to do 6 minus 15. 6 minus 15 is a -9, which is part of my answer already. Then 4 minus 6, just subtracting the pieces in the same spot. 4 minus 6 is at -2. Get to the bottom row now. 12 minus 18 is -6. And lastly, in the bottom row, 2 minus 21, which is my -19. Because this matrix, when I do all the subtractions that are implied, fits perfectly with that matrix, then my answer that my calculator got is perfect. I'm going to do again 14 on my calculator so I know what the answer is ahead of time. So to do this on my calculator, I'm going to go second matrix, stay under the names, activate the E, then hit the minus that's below the times and above the plus, and then second matrix, stay on the names and go to C. So that's what my calculator needs to see for E minus C. And the answer that it shows there is what I should be able to duplicate by hand, unless I happen to enter one of the matrices wrong, because that part of the screen looks perfect to me. I don't see anything messed up. So lots of zeros and ones, small numbers, so that's good. So let me see if I can get that by hand. I'm going to copy this answer down here so that it was 1, 3, 1, -3, -1, 0, 0, 3, 0. So doing this without knowing the answer ahead of time would be not that hard. I would write the E matrix first, which is 2, 3, 0, 4, 1, 4, 2, 6, -5. Then I'll put my minus sign, and then I'll have my C matrix second, which is 1, 0, -1, 7, 2, 4, 2, 3, -5. I'll do the subtraction. Upper left, I get 2 minus 1, which is that 1. Upper middle, I get 3 minus 0, which is that 3. Upper right, I get 0 minus a -1. The double negative turns into a positive, which gives me a 1. And then middle, first 4 minus 7, which is that -3. And then 1 minus 2, which is that -1. And then 4 minus 4, which is that 0. And then bottom row, first 2 minus 2, which is that 0. And then 6 minus 3, which is this 3. And then -5 minus a -5, and that's that 0. So the answer that my calculator gave me fits perfectly. It's a logical step from there to there because all those subtractions yield those numbers. So my answer is correct for problem 14. And that's all there is to do for that. Adding and subtracting and scalar multiplication, they're the easier operations for matrices. 15 to do A times E. I'll set it up and then I'll do it on my calculator. So A times E wants me to take matrix A, which is 1, 0, 3, 2, 6, 1. Write that first, and then next to that, write matrix E. This is going to be a not possible. My calculator is going to give me a dimension mismatch error. I'll just do it by hand. Well, let me do my calculator real quickly, then I'll do it by hand. So on my calculator to do this, I would clear this out, do second matrix, first names A, and then second matrix, and then down to matrix E. So that's how my calculator needs to see A times E. When I hit enter, it's going to give me dimension mismatch because these aren't possible. My answer, I'm going to say it's not possible. So when you're trying to multiply or add matrices, if you get a dimension mismatch error, then those matrices can't, that operation doesn't work for those matrices. So here I get error dimension mismatch. So my answer to this is just going to be not possible. These can't be multiplied. If I wanted to do this by hand, the first thing I would do is take this row 1, 0 and write it next to the column 2, 4, 2. So I'd go 1, 0 and then 2, 4, 2. And then I'd multiply across and add. Because there's a blank here, there's nothing to multiply here. This is why it's a dimension mismatch. When I wrote the top row as a column and put it next to the first column in the E matrix, you see the dimension mismatch. You don't get it lined up perfectly, and I wouldn't even have to go further because it's just not possible. Anything else I might write is just to further emphasize that it's not possible. Because it's not possible, I'll just stop. 16 wanting me to do FA, that is going to be possible. And it's going to be tedious to do by hand, simple to do by my calculator, so I'll do it on my calculator first. So clear second matrix names F first, and then second matrix names A second. And when I do F times A, hey, F, oops, it's supposed to be A times F, I'm sorry. I'm changing this to be A times F. No, I did something, I just clear. I did FA, and that doesn't work. AF doesn't work either. I'm changing this problem as we speak because I want a multiplication to work. Let me do AB. So I'm going to change problem 16, and when you print it out, it's going to say AB because I want a multiplication that's not a dimension mismatch. FA, the problem that was on there, is another dimension mismatch, and I didn't want to write not possible, not possible, not sure I had to do a multiplication that worked. So I'm going to, when I actually get back to my office, I'm going to change problem 16 to say find AB as opposed to FA, and now I'll do AB, second matrix A, which is going to be the problem on the review when you finally get to the review. And AB is that matrix, and that's going to be the answer that the new problem 16 has. So 4, 5 for the top row, 14, 19 for the middle row, and 25, 32 for the bottom row. So I'm going to copy that down and say the answer to this, the new problem 16, which will be the permanent problem 16, is the matrix that has 3 rows and 2 columns. And I'm just scribbling it down, mindlessly copying from my calculator. And now I'm going to make my algebra fit my calculator. So to do AB, by hand, I'd write the A matrix 1, 0, 3, 2, 6, 1, and then next to it the B matrix, which is 4, 5, 1, 2. And because A has 3 rows, has a top row, a middle row, and a bottom row, that's why my answer has a top row, a middle row, and a bottom row. I'm going to get the top row first for my answer by taking this 1, 0, writing it as a column, first writing it next to the 4, 1 column, and then taking the 1, 0 again and writing it next to the 5, 2 column. So to get the top row of my answer, I use the top row of the left matrix. I write the row as a column and write it next to the columns. Here I go, 1 times 4 is 4, 0 times 1 is 0. I add 4 and 0 and get 4. That's why there's a 4 up there, the first thing in my top row. The next, I go 1 times 5 is 5. 0 times 2 is 0. I'm multiplying across. I'm going to add down 5 plus 0 is 5. The top row of my answer is supposed to be 4, 5, which it is. Done with the top row of A, I'm going to move on to the middle row of A to get the middle row of my answer. I'm going to write the middle row 3, 2 as a column. I'm going to multiply it by 4, 1, and I'm going to multiply it by 5, 2. I multiply across, then I add. The multiplication, taking the 3, 2 times the 4, 1, I go 3 times 4 is 12, 2 times 1 is 2. I add and get 14. That's why there's a 14, the first thing in the middle of my answer, middle row of my answer. And then doing the 3, 2 times the 5, 2, I go 3 times 5 is 15, 2 times 2 is 4, 15 plus 4 is 19, and that's correct. Done with the 3, 2 row, moving on to the 6, 1 row, which is going to be the bottom row of my answer. I'm going to write the 6, 1 as a column, write it next to the 4, 1 again, and write it next to the 5, 2. Multiply across, then add. 6 times 4 is 24. 1 times 1 is 1. I add 24 and 1 and get 25. And then lastly, 6 times 5 is 30. 1 times 2 is 2. I add and get 32. If you look at my top row, it's supposed to be 4 and 5. There's a 4 and 5. My middle row says 14 and 19. I see 14 and 19. Bottom row says 25 and 32. I see the 25 and 32. So my work ties perfectly with my calculator's work, and that's what I need to see. I need to see the work to get to the answer, not just the answer. So if you just write down an answer and don't show me how you generated the numbers, you're not going to get credit. All right. 17, solving with a square. It means I have to use substitution. Elimination won't check, and RREF won't do me. These are one of the only problems on this review that I can't know the answer ahead of time. So I'm going to do the answer, then check it. So I'm going to solve the top for x to start, doing the next two problems using substitution. To solve the top for x, I'm going to add 7y to both sides and get x equals 7y minus 4, which is going to be useful when I finally get to do my answer. There's going to be two answers probably because there's a square in this. Now I'm going to substitute into the bottom equation. I'm going to change the x in the bottom equation to 7y plus 4. Numbers are going to get a little bit big, but that x squared is going to go to actually 7y minus 4 squared. To square this, I'm going to rewrite this as 7y minus 4 times 7y minus 4 and do the foiling. The firsts are 7y times 7y, which are 49y squared. The outers are 7y times minus 4, which is minus 28y. The inners are the same, minus 4 times 7y, it's another minus 28y. The last, minus 4 times minus 4, is a positive 16. I still have the y squared, and I still have the equal to 10. Now I'm going to combine terms. I have a 49y squared and then a 1y squared. I'm going to add those together to a 50y squared. These two minus 28y's, they have the same signs. I'm going to add the 28s and get 56 and keep the negative sign, so those will be a minus 56y. And then for the 16, I'm going to subtract 10 from both sides to get that 16 turned into a 6. So I have a problem that has an equal sign and a numerical common factor. I can divide that away. So I'm going to divide away a common factor of a 2. And when I do that for problem 17, I get 25y squared minus 28y plus 3 equals to 0. I can factor that. If you can't factor that, then you need to use the quadratic formula. If you want to factor, it's probably bottoms up for you. I'm factoring in my head because I can. That factors into 25y minus 3 times y minus 1. Again, your bottoms up factoring would take you there if you can't factor in your head. If you didn't know how to do bottoms up factoring, you could use the quadratic formula. Quadratic formula, factoring in your head, and bottoms up factoring, if they're done right, will all lead to the same two y's. My factor of 25y minus 3, if I add 3 and divide by 25, I get 3 over 25 for one of my y's. My y minus 1, if I add 1, I get y equal to 1. I'm going to get my answer on my next page because I don't have enough room to keep it clean here. So I solved the top equation for x, which is going to come in handy when I go to solve for x. I substituted, did a bunch of work, and got two answers for y. Now for each y, I need a corresponding x, and then I'm going to check. So to finish up problem 17, I'm going to use my y's. Hopefully that last stuff just stayed on. Yeah, it should be on the screen fine. I'm going to use my two y's, which were 3 over 25 and 1. And I'm going to use the equation that I came up with, x equals 7y minus 4, and get my answers for x. So for the first one, I'm going to get x equals 7 times 3 over 25 minus 4. Break out my calculator to do that, but I can do it by hand if I wanted to. Easier on my calculator, so I'll use my calculator to do 7 times 3 divided by 25 minus 4, and then math, enter, enter. I get negative 79 over 25 when I do that. And I say, pairing this x of negative 79 over 25 with the y gives me one of my answers. So the answer that this gives me is negative 79 over 25 for x, 3 over 25 for y. That's going to be unpleasant to check, but it will check, and I will check it just to make sure I'm not writing down a wrong answer. The second answer is going to be a lot easier. Plugging y equal 1 into that, I get x equals 7 times 1 minus 4. I don't need my calculator for that. That gives me x equal to 3. That gives me the second, what I think is the solution, as 3, 1. So now I'm going to check. I'm going to use my calculator to do the hard checking, the fraction checking with the negative 79 over 25 and the 3 over 25. That's tough checking. I don't need to check by hand if I don't want to. What I need to do to check is pull back the original equations. The original equations were x minus 7y equal to negative 4, and x squared plus y squared equals to 10. Ooh. So for the first checking, it should be the case that negative 79 over 25 minus 7 times 3 over 25 equals negative 4. So this is the checking part. And do that on my calculator. Hope that when I do this left side, when I hit enter, I get negative 4. So I'm going to go negative 79 over 25 minus 7 times 3 divided by 25. If it doesn't say negative 4 when I hit enter, then I'm worried. But it does, so it checks in the top equation. Now I'm going to check it in the bottom equation. Same two values. I'm going to go negative 79 over 25 squared plus 3 over 25 squared. And that best equal to 10. Same deal, I'm going to do this checking on my calculator. Hopefully I get a 10 equal to 10. So I'm going to clear out what I have in there and go parentheses, negative 79 divided by 25, close my parentheses, squared, plus parentheses 3 divided by 25 squared, and I wrote 2 divided by 25. That was going to mess me up. That looks good enough. I don't know if you could see it, but it is what it is. I've entered it right, and it gives me 10 equal to 10. So both of those check. I didn't even really show the checking on my paper, but this one did wind up giving me negative 4 equal to negative 4. This one gives me 10 equal to 10. The other checking, to do the 3, 1 into this equation, I'll do 3 minus 7 times 1 equal to negative 4. That gives me 3 minus 7 equal to negative 4, which is negative 4 equal to negative 4. And in the bottom one here, I'd go 3 squared plus 1 squared equals to 10. That would be 9 plus 1 equal to 10, which is 10 equal to 10. So both of my solutions that I came up with are correct. Because the equation started off with a square, I expected to get no more than 2 solutions, and that's what I wound up getting, so I feel good about that. And my answer's checked. Not many more problems to go. One more kind of grungy problem, and then the graphing problems, they're not that bad, so I won't, those should be nice. So just like in 17, I'm going to solve the top equation for x. All the problems that have the squares or the cubes, they're easy substitution problems. So the top equation is x plus 2y equals 11. I'm going to minus 2y from both sides. I can't do this using RREF because of the x squared. I could probably do the elimination method, but if I tried to do the elimination method, I'd probably make a common mistake and generate an answer that doesn't check. So now that I have this, and I could have written negative 2y plus 11, but it's probably just as easy to write it like that. So in this equation, x squared plus y equals to 13. I'm going to change the x to 11 minus 2y. So I'm going to get 11 minus 2y squared plus y equals to 13. I'm going to FOIL this, going 11 minus 2y times 11 minus 2y. That 11's not good because it's going to turn into a 121. So as I FOIL this, first are 11 times 11, which is 121. Outers are 11 times minus 2y, which is a minus 22y. Inners are minus 2y times 11, which is another minus 22y. Last, minus 2y times minus 2y is plus 4y squared. I still have the plus y, and I still have the equal 13. To get the problem set equal to 0 and combine like terms, the 4y squared I'm going to write first. It doesn't have anything to combine with it, so it's just going to be part of the left-hand side. And then I have a minus 22y, a minus 22y, and a plus 1y that need to be, those three y's need to be made into a single y. Minus 22 and minus 22 is minus 44, plus 1 is going to be minus 43y. And then for the 121, I'm going to minus 13 from both sides. When I minus 13 from 121, I get 108, a positive 108. And on the right side, 13 minus 13 is 0. Oh, I can't factor. I probably could factor that, but I don't care to factor that. Okay, so I'm going to use the quadratic formula because that factoring, the 108 is such a big number that I'm not going to attempt to factor it. So I'm going to use the quadratic formula. I'm going to make A equal to 4, B equal to negative 43, C equal to 108, and I'm going to get y equals to negative b, which is negative 43, plus or minus the square root of b squared, which is negative 43 quantity squared, minus 4ac, which is 4 times 4 for the formula, 4 for the a, and then times 108 for the c, all over 2a, which is 2 times 4. I'm going to get 43 plus or minus over 8. I'm going to do that entire square root on my calculator slickly. So on my calculator, I'm going to go enter that perfectly like it is. I'm going to go second square root and then another parentheses for the negative 43 squared. So there's negative 43 squared minus 4 times 108. And then close out the parentheses. So essentially what I've done is I've entered a big parentheses to get all this under the square root, and then I did the negative 43 squared in a parentheses, the 4 times 108 in a parentheses, and I've got the square root going, so it's going to just do this for me, and apparently that equals 11. So this right here, I did all this, did the square root on my calculator. And that's completely legal to do. I have no problems with you doing grungy big numbered arithmetic on your calculator. That's probably preferred. So now, because the square root went away, I get the two problems that are implied, which is 43 plus 11 over 8 and 43 minus 11 over 8. The 43 plus 11 over 8 is 54 over 8, and I can reduce that, but I'll cheat. 54 divided by 8 equals, math, enter, enter. That's 27 over 4. It reduces by 2. So I get y, actually, yeah, just by 2. For some reason, I thought it was going to reduce by 4. And for this one, 43 minus 11 is 32, and 32 over 8 is 4. So I get two answers for y. I need to get the corresponding x's, and then I need to check. So when I go to get my answer for 18, there's going to be 2 points again for my answers. Unfortunately, just like in the last problem, well, one of the points is going to be a fraction point, but it's not going to be horrible. So as I get into finishing up problem 18, I need to get, for each y, I need to get an x, and then I need to check. So for 18, my algebra gave me y equal to 27 over 4 and y equal to 4. I'm going to use x equals 11 minus 2y to get my x's. The first one's going to be x is 11 minus 2 times 27 over 4. And again, I'm going to lazy mode here, end of the semester, and I know I can do fraction work by hand if I really had to, but I don't have to, so I'm not gonna. So I'm doing this work on my calculator. My calculator gives me negative 5/2 for this one. So for this, I get x equal negative 5/2, which is going to give me a potential answer of negative 5/2 comma 27 over 4. The 4 is going to be a lot easier to deal with. I'm just going to go x equals 11 minus 2 times 4, which is x equals 11 minus 8, which is x equals 3. That's going to be the 3, 4. So I think that the answers to problem 18 are the point negative 5 over 2 comma 27 over 4 and 3 comma 4. Before I commit to those answers, I'm going to check. So I make sure that this work actually showed up, just in case I trimmed out some of the bottom down here. That's the work from the last page that I did. I'm going to pull off the problems, the equations x plus 2y equal to 11 and x squared plus y equal to 13, and use my checking. So the two equations that started this problem were x plus 2y equal to 11 and x squared plus y equal to 13. When I go to check the first one, and leave myself a lot of room, I'll go negative 5/2 plus 2 times 27 over 4 equals 11. And I do that on my calculator. So for that, I'm going to go negative 5 divided by 2 plus 2 parentheses 27 divided by 4. And when I hit enter, it gives me 11. So that is a checking. It checks there because I get 11 equal to 11. And then in the bottom one, I'm going to go negative 5/2 quantity squared plus 27 over 4 and see if I get 13 equal to 13. So this is the checking part. And easy enough to check again. For this, I'm going to go parentheses negative 5 divided by 2 squared plus 27 divided by 4. And when I hit enter, I hope to see 13 like I did see 13. I don't know if you can see it, but I can see the 13. So that's a true, that solution works because it gives me a true statement. For the 3, 4, I don't need a calculator. Going to this equation, going 3 plus 2 times 4 equals to 11. This gives me 3 plus 8 equals to 11, which is a true statement. And then going to the bottom one, I go 3 squared plus 4 equals to 13. That gives me 9 plus 4 equal to 13, which is 13 equal to 13. So this is just more checking here. So because both the answers that I came up with check in both equations, they're both solutions. And I have 2 different points for my answers to problem 18. So done with the grunge. Kind of done with the stuff I could really check, unfortunately. The last 2 graphing and shading problems, I don't really know how to check so nicely with any technology. So I'm just going to live with these. Immediately, both of these problems, I see the comments x is greater than or equal to 0 and y is greater than or equal to 0. This is going to keep my graph in the first quadrant. So these 2 by itself just tells me the graph, the final shading area is going to be remained in the first quadrant. And I'm not even going to graph those. Well, I might show them a little bit. Technically, the x is greater than or equal to 0 is the y-axis, and you shade to the right. And the y is greater than or equal to 0 is the x-axis, and you shade up. So I'll try to show those, but you can't really see them that well. So for the x is greater than or equal to 0, this is the line x equal to 0. And for the greater than part, I shade to the right. So I needed to do that. And then this line is the line y equal to 0. And for the greater than part, I need to shade up. So for those two shadings are going to overlap going to the right of the y-axis and above the x-axis. This is why I say those two keep me in the first quadrant. For the next two, I'm going to find my x and y intercepts. So I'm going to graph the line x plus y is less than or equal to 6, or graph the inequality. First, I'm going to look at the line x plus y equal to 6. Plug 0 in for x and get 0 plus y equal to 6. That gives me y equal to 6. That's going to give me the y-intercept of 0, 6. So here I did let x equal to 0. And now I'm going to let the y equal to 0 and get x plus 0 equal to 6. That gives me x equal to 6, and that's the point 60. So for the graphing part of this, I need to find 6 on the x-axis, 6 on the y-axis. I get a nice solid line because of the or equal to part. And then I need to check for shading. So for shading, I'm going to plug 0, 0 in. If I get a true statement, I'm going to shade over the 0, 0 and shade down. If I get a false statement, I'm going to shade away from the 0, 0 and shade up. So I went to the equation x plus y is less than or equal to 6. I got a true statement. That means my shading needs to go down. And I really only need to stay in the first quadrant. So I'm going to just make a little note to myself how the shading is going to look before I actually darken it in, because I can't erase so well with this. Really, I'm not content with what I have for 19, but I'm going to live with it here. I'm not happy with what I have here. So for this one, 2x plus y is less than or equal to 11. I'm going to get the x and the y-intercepts of the line 2x plus y equal to 11. I'll start off letting x equal to 0. Gives me 2 times 0 plus y equal to 11. That winds up with y equal to 11, which gives me the y-intercept of 0, 11, which is going to be up here somewhere, 11 on the y-axis. And then I'll do similar for the x-axis. I'm going to let y equal to 0. When I let y equal to 0, I get 2x plus 0 equals to 11. I get 2x is 11. X is 11 over 2, which is 5.5. So the x-intercept is 5.5 comma 0, which we'll mark right there. It's not exactly perfect. And this line, I'm going to draw with a solid line. I'm going to figure out which way to shade it. And again, I'm going to check the 0, 0 to see if I get a true statement or not. Go to the original problem. 2 times 0 plus 0 is less than or equal to 11. This gives me 0 is less than or equal to 11. Because that's true, my shading needs to cover up or go towards the 0, 0. And now I'm just going to emphasize where the shadings overlap. So I need to be in the first quadrant beneath both the pink line and the blue line simultaneously. So that's the region that is, this is the graph. I kind of labeled the corner points. I have a corner point there along the boundary, and that's the point 0, 6. I have the origin as a corner point, which is the point 0, 0. I have that x-intercept as a corner point, which is the point 5.5 comma 0. This 11 up there is not a corner point because it's not around the final shaded answer, and this 6 is in the corner point. I also need to find that point, and to find that point, I'm going to enter that as a 2x3 system of equations and do RREFA, not do a lick of algebra to get that. I've done enough algebra, and I know that you can do this if you had to. So I'm going to enter that, pretending it had an equal sign, as a 2x3 equation. Do 1, 1, 6, 2, 1, 11. And then second quit, second matrix math, RREF, second matrix names, A, that's going to be the 0.51. That's a corner point because it's on the boundary of the shaded region. So this is everything for problem 19. I graphed the trivial inequalities, just say my final shaded region can't go outside of the first quadrant. I made sure to do that. And then I graphed the line that had x-intercepts and y-intercept at 6, shaded down. Graphed the line that had a y-intercept of 11, x-intercept at 5.5, shaded down. Shaded everything down, stayed in the first quadrant, labeled the corner points where the shading exists, where all the shadings overlap, and cheated to find that point right there. Hardly looks like the 0.51 on my graph because my graph isn't drawn to any sort of accurate scale, but for this sort of problem, unless we start getting more things to graph, our graphs don't need to be any more accurate than this. If you take Math 218, you'll start doing these sorts of graphs again and need to have graph paper and make your graph a little bit more accurate than this, but this is more than accurate enough for what we're doing. So that's perfect for number 19. And then we'll always just have one left. Scribbling to myself what the answer is on another sheet of paper here so I don't forget. All right, the last problem. Problem 20 needs me to graph the four inequalities again, and just like in the last problem, these tell me I need to stay in the first quadrant. The x is greater than or equal to 0 is going, that's the line, that's the y-axis, and I shade to the right. So the y-axis is the line x equal to 0. So there's the line x equal to 0. For x greater than or equal to 0, that line I need to shade to the right. This is a graph of y equal to 0. For y greater than or equal to 0, I need to shade up. So those two inequalities simultaneously just tell me I need to be in the first quadrant. Now I'll work with the x plus y is less than or equal to 8. I'll find both the x and the y-intercepts of the line x plus y equal to 8. If I let x be 0, I get 0 plus y equal to 8. That gives me y equal to 8. That's going to give me the point 0.8, and I'll just guesstimate. That looks like 0.8 to me. And then for that same bit, if I let y equal 0, I get x plus 0 equal to 8. That gives me x equal to 8. That gives me 8, 0 on the x-axis. And again, I'll just kind of guesstimate that as the 0.80. I might need to extend my x-axis a little bit. Who knows? And for shading, I'm going to check 0, 0. So I'm going to check into there. Zeros, oh, I need to draw this. Solid line because I have the or equal to. So that's a reasonable graph. Now I'm going to check the point 0, 0. I see that I get 0 plus 0 is less than or equal to 8, which gives me 0 is less than or equal to 8, which is true. So this shading, I know it needs to stay down. It also needs to stay in the first quadrant. So that blue line I would shade and stay in the first quadrant. You'll see that I don't have any greater thans on the review, which means I probably won't put any greater than shadings on the test, other than the trivial greater thans. The next one, the x plus 2y is less than or equal to 10. I'm going to find the x and the y-intercepts on x plus 2y equal to 10. First, I'm going to let x equal to 0 and get 0 plus 2y equal to 10. That ultimately is going to give me y equal to 5. And graphing-wise, it's going to be the 0.05. And again, I'm just going to estimate that 0.05 crudely. And if I do something similar and let y be 0, I'd go x plus 2 times 0 into the equal 1 equals 10. This is going to give me x equal to 10, which is going to let me graph the point 10, 0. So the equal part of the x plus 2y is less than or equal to 10 graphs like that. Now for shading, I'm going to check 0, 0. So for shading, I'm going to check 0, 0. I go 0 plus 2 times 0 is less than or equal to 10. This gives me 0 is less than or equal to 10. So this shading needs to go in the direction of 0, 0. So this shading needs to stay in the first quadrant and go in the direction of 0, 0. Just like the last problem, this sort of region beneath the pink line and beneath the blue line is the final overlapping of all the shadings. The corner points are this point 0, 5. The origin 0, 0. This point 8, 0. And this point that I don't have yet, I'm going to find on my calculator using RREFA, doing those two equations simultaneously. I can't use my graph to get the answer because my graph isn't accurate enough. So I'm going to enter this as a 2 by 3 matrix, and that looks like it's the 0.62. I did RREFA, and so the final corner point, because it asks me to label around the final shaded region the corner points, and that's what I've done there the best I can. So that graph with the corner point 62 labeled, the corner point 05 labeled, the corner point 00 and 80 need to be labeled. The other intercepts, the other y-intercept of 08, the other intercept of 10, 0, you don't have to label those. They're on my graph already. They're not wrong to have them labeled. But at a minimum, I'd expect to see those 4 points on the answer to this problem, because where the all the shadings converge and overlap, those are the points that where the lines intersect. Okay, so hopefully this isn't a nightmarish test and you do reasonably well. And then we just have one chapter left. It only has 3 sections. The notation's a little grungy in that section. So algebraically, it's not that complicated, but visually, it looks more complicated than it is. So don't get intimidated when you look at when you start section chapter 9 by the notation. Hopefully, I explained the notation well enough that it's just really not that hard. The notation looks impressive, so if somebody's watching you do the work, it'll look like you're doing something really hard when it's not really that hard.